Okay, so today we're going to show you how to make a custom speaker box using Vectric V Carve, and this will be cut out on our STEPCRAFT 840. So the idea here is in the car audio industry, or when you're looking to make a speaker box for your car, typically people will use a table saw, which means all of your sides are going to be square or rectangular. Very hard to do curved boxes or things like that, and up until now with a CNC, in order to get curved shapes and do things like that, you'd have to use foam and cut it out, and then use fiberglass, and it's very time consuming, and it's a skill. It's definitely a skill. So what we're doing here is we've got a speaker box that we are going to make for the back of a vehicle, and it's actually for a JL Audio 6-inch subwoofer. And this is what the box looks like. There's actually 12 pieces to it. There is the left panel, there's the right panel, which is where the speaker is going to get installed, and then there are the internal splines. Now this is made out of 3/4 inch MDF, and what's going to happen here is we are going to essentially stack all of these pieces together and glue them, and when we're done, we're going to end up with a speaker box that has a curved shape here and a curved shape here, as well as a port that's already built into the box. And the volume's already been pre-calculated based on the number of pieces. So this is going to require one left panel, 10 splines at 3/4 of an inch thickness apiece, and one right panel. So that's what we're working on, and this is where we're going to get started and bring this drawing into the V-Carve to lay out our tool paths. Now, this particular speaker box has been drawn in Adobe Illustrator, and it is to scale. So you would be responsible for picking a drawing program that best suits you, whatever you're comfortable with to draw. You could use a CAD program, you could use Illustrator, you could use free drawing software like InkScape, you could use CorelDRAW. The possibilities are endless. It doesn't matter really what you use, as long as you can get a vector file output to bring the components into Vectric. Okay, so the first thing we need to do is we need to create a new file. Now, I'm using V Carve Pro. You may have V Carve Desktop, or you may have Cut2D. The desktop version of both V Carve and Cut2D have a size limitation. That's one of the differences, where they're limited to 600 by 600 millimeters that's the maximum your job size can be. Now, Pro it has a lot of other features in it as well, but the most prominent one is going to be an unlimited work size. And since this box is intended to be cut out on a STEPCRAFT 840, which has a work area of 840 millimeters by 600 millimeters, I'm going to use the Pro version because I actually want to show you in this video that what you could do with a larger work area, seeing you have a bigger machine. Now, if you have desktop and you realize that you want to use Pro, you can always go upgrade, pay the difference. You go to Vectric's website and you can upgrade to Pro at any time there. The other option would be to set a 600 by 600 work area size, and then you can tile the job so that you have you're either working with smaller work pieces, or you would cut part of the job and then move the head to a new starting position and run the second part of the job to use up the rest of the workpiece. So with V Carve Pro, first thing we're going to do is create a new file. Now, this particular file, we're going to use a piece of material that's 22 inches wide by 32 inches long. So that's going to fit on the T-slot table on the STEPCRAFT 840 and still give me some room to clamp on there. So the actual piece of work material is a little bit longer. It's about 1.5 inches longer in the y-axis, so that I have room for my clamps. Now, the material thickness is 0.75 inches. I recommend you get a pair of dial calipers, which you can get from Harbor Freight or someplace like that for less than $10. The digital kind is what I recommend. Always measure your work material. Don't assume that just because it's 3/4 of an inch when you buy it, that's what they say it is, that it is actually 3/4 of an inch, because it might not be. In this case, it was. So I'm going to set that as my material thickness. Your material Z, I always set it usually with MDF to the top of the work material, meaning that the Z is what moves up and down. That's what your tool is connected to. So when you start this job, you're going to touch off the tool on the top of the work material, and that's going to be the 0. So any cuts you make will be into the wood from that point. You could also click here and you could touch the tool off on the bed or on top of your spoil board, and that would work fine too. I just typically use the top as a standard. Now if my board was plywood and it was really warped and it had high spots and low spots, I would choose to touch it off on the bed. That way it doesn't matter. The cutters, if I tell it to cut 1/8 inch per pass, it's going to cut through regardless of whether there's a high or a low spot. It's going to finish on the bed. So that way I don't have to worry about some parts getting cut out and some parts having some material left because the material's warped. So we're just gonna set the top on the Z. This is your starting position. 2 positions I typically use. Bottom left, and it's indicated by this red mark here. That's where you would move the tool manually in UCCNC when you clamp this board down. You would move it so that the tool is in this position. You got to remember that the CNC machine has no idea what you're putting on there for material, how thick it is, how big it is. You have to give it some sort of a reference point that it can start working from. Usually I use the lower left, and I make sure that the edge of the material is parallel to the edge of the machine, so as the tool moves in this direction, it doesn't veer off or cut in too far. The other option is you could use the center of the board, which you would just measure the center of your workpiece. You would manually move the tool to that spot and you would zero it off in UCCNC. So in this case, we're going to use the lower left. We're going to make sure we're in inches. The modeling resolution and appearance does not matter for this particular job, so we're going to ignore that and we'll just click OK. So here we go. So now what I need to do is, we've got the drawing that was already done in Adobe Illustrator for the box. And again, you could use any CAD program. Just any vector image file is all you need. So in this case, we're going to import those vectors. We're going to go to File menu, click Import, and we're going to click Import Vectors. Now, I already have a folder here, and the JL Audio sub box is what I'm going to pick. And here are the 3 components that you saw earlier in the PDF file. Now, this is just lettering here that we put in the drawing just to indicate a note as to what each panel was for. Now, I don't need those. I'm not going to CNC those. So I'm actually just going to highlight them, and then I'm going to hit the delete key and get rid of them. Now, you have a few options here. You could see you got the 3 pieces. You could see this is my work area. Now, I can manually move these pieces around to optimize them so that they fit in the work area, and I try to minimize the waste as best I can. And that's one way to do it. I could select this. I can go over here to the move, scale, rotate function and just basically move my my mouse over, hold down the mouse button, and I can move this piece wherever I want. And I could even click over the darker square and I could rotate it. So I can position it any way I want here, and I could take a few minutes and go ahead and do that and position everything manually, and everything would be fine. However, V Carve Pro has a feature that's called auto nesting. Now, one thing you gotta remember is that this center piece here, this one here, has to be there has to be 10 copies of that. So I know just by measuring this out that I'm going to be able to get at least 4 of these pieces on one sheet of MDF. So I'm going to actually highlight this piece, and I'm going to click, I'll right click instead of using keyboard shortcuts. I'm going to right click and click copy. I could also hit Control C, which is the keyboard shortcut. And then I'm going to right click again, and I'm going to click paste, which again, I could also do Control V. Now it's going to copy it and paste it right over. So I'm going to move it over here so it's out of the way, and you'll see that I have 2 copies of that now. So now I have 4 components on my worksheet. What I'm going to do is I'm going to highlight them all so they're all selected, and then there is this nest selected objects feature here, and I'm going to click on that. Now what I'm going to do is I have to tell it what the tool diameter that I'm working with is. In this case, I'm going to use a 1/4 of an inch end mill. This is going to tell me what is the clearance that I want between the tool and the edge of the next piece. So if I put this to 0, the tool, and I set that my tool diameter to a 1/4 of an inch, it's basically the tool is going to run right between two pieces, and there's no room for error there. So I tend to, whatever the tool diameter is, I put that in for clearance. So I've got a 1/4 of an inch clearance. And I've got a border gap, which is all the way around the workpiece, of 3/4 of an inch. Now I'm choosing to rotate the parts to best fit, and my rotation angle, it's going to work in 45-degree steps. You can make that anything you want, but basically I'm giving the program permission to rotate objects as necessary to get them to fit with a minimal amount of waste on this workpiece. I can also choose to mirror parts for best fit. In this case, it won't really matter because all the parts are kind of rectangular. But if you had some really complicated or intricate parts, you might want to check that, and you'll see when you do the preview that it may arrange to get everything on one piece. Now I'm going to allow to fit parts inside of other parts. In this case, I don't want to do that. It wouldn't really matter anyway because none of these parts are going to be able to fit inside. But this part here is going to be cut out hollow. Same thing with here. Now, for some reason, I had a small part that was going to be part of this box. Maybe it was a port, maybe it was a handle, something like that. If I check that, it'll actually put that part inside here because this is all going to be waste in here. So it would put those parts inside here and minimize the amount of waste that we have. I'm going to leave it checked because it won't matter. Now, you have two options. You can nest along the x-axis, which is left to right, or you can go along the y-axis. Now, I usually will check this. I start with the X, and then I click Preview. And you can see what it did here is it gave me 2 parts on this sheet, and then it made a second sheet and put the other 2 parts on. Now, that's not going to work for me because this is a lot of wasted space. So the other option is I can go back here and reset the preview, click along Y, click Preview, and see if it did any different. And this time it still did 2 sheets, it just rotated them differently. So I know we're going to want to go along the X. Now, one of the problems might be my 3/4 inch here. If I set this to 0 and click Preview, you could see now all of a sudden all 4 parts fit on one sheet. And I've got a 0 border gap around. It's not really pertinent that I have one. What I'm looking for is I want to make sure that the edge of the line where the material is going to be cut is not on the edge of the workpiece. Because if for some reason this material was in crooked or something, I run the risk of having the cutter come out here and not actually cut on the line where it's supposed to. MDF doesn't have any grain, so I don't care about trying to line grain up or anything like that. It's a manufactured product, so it really doesn't matter. But as long as I have a little gap there, now I could experiment with it, and I could put 0.25 and give it a 1/4 of an inch, and then click Preview, and you could see that pushes the other 2 off. So I don't necessarily want to do that. I could try an 1/8 of an inch, click Preview, and that puts them all on one. So I think I'll leave an 1/8 of an inch. It just gives me a little bit more cushion here and here on the material. So now that I've done that, I've got everything set up. I like the way this is nested. I'm going to get 4 parts on a sheet with minimal waste. So I'm going to click OK. And that's it. Now I'm ready to cut these parts out. Now keep in mind, I'm going to have to come back in after, and I'm going to have to take this piece here, and I'm going to have to copy it so that there's 4 on one sheet. And the process is the same. I'm basically going to delete these 2, and I'm going to make a copy of these 2 and move them over. So now when I nest it, I have 4 of these. And I've got 2 here, and then I'm going to do 2 more sheets, which are going to have 4 and 4. So that's the 10 that I would need total. Now, the next part is, this is it. This is what we're trying to do. We need to get this all set up so we can cut these parts out. So everything that we're doing here is, for the most part, is going to be a profile outside the line cut, meaning we want to cut along the outside edge of the lines because this is drawn to scale. The only exclusion from that is going to be the speaker cutout, because this is also drawn to scale for what we need for the speaker. So if I click on this and select cut outside the line, now my hole is going to be too big. It's going to be a 1/2 inch diameter too big because I'm using a 1/4 inch end mill. So I'm going to want to make sure that I do a tool path for the hole that's separate, and I'm going to want to cut inside the line for that. So the other thing that you got to keep in mind is whenever you're laying out a CNC job, anything that's an interior cut, you want to do first. So I don't want to cut this piece out and then come back and try to cut this circle out, because this piece is just going to move around and there's no way to clamp it down. I want to keep it secure in the entire work area for as long as I can. So what I'm going to do is I am going to click on this button here, which is switch to toolpaths tab, and I am going to actually I'm going to pin this. Let's see, I want that pinned, and then I'm going to come back to the drawing tab and I'm going to pin that, so I have both tool paths there on either side, so I can bounce back and forth if I need to. So the first thing I want to do is cut this circle out. So I'm going to highlight the circle. I'm going to go over here. These are the different tool operations you have, and I'm going to do this one's profile toolpath. I'm going to click on that. I'm going to basically, my start depth is 0. 0 is the top of the work surface. So I have no reason to start any different point than that. I want to cut all the way through. My cut depth, I want to go down through the material. So because it's 0.75, I think I'm going to go 0.765. And that way I'm sure I'm going into the spoil board and all the way through. Now I'm going to have to select my tool here. And in this case, I've got some tools set up already. I want to use a 1/4 inch end mill. I have metric tools set up here and specialty tools, and it's pretty easy to do. Now, what I'm going to do is I'm going to select this 1/4 inch end mill, and I'm going to copy it. And the reason I'm doing that is because you can run a 1/4 inch end mill on different materials, and your depth per pass and your feeds and speeds are going to be different depending on those materials. So in this case, I want to make a copy, and I'm going to call this one MDF. So this is going to be my go-to tool all the time. Whenever I cut 3/4 inch MDF with a 1/4 inch end mill, I'm going to pick this one. Now, from the get-go, one of the things that we have to do is we have to set up the parameters. Okay, so the diameter of the tool is already set. It's a 1/4 inch, and that's your cutting diameter. The pass depth. Now, typically, as a rule of thumb, for the first go, our pass depth is usually half the diameter. So in this case, it's 0.125 or 1/8 of an inch. Now, depending on which spindle you're using and the material, you may find that you can go a 1/4 inch. You may find you can go 5/8, 3/8. It doesn't, it doesn't matter. You as you go along, you'll determine. You'll hear it. And if it's cutting really easy and it's not straining and you're moving it fast, you may be able to go back and say, okay, instead of 1/8 of an inch, let's go to 0.25 for cut depth and see how that works. But a good rule of thumb, always with new material, is to start off at half the diameter, except for metals. Metals are a completely different story, and we're not going to get into that here, but that rule of thumb does not apply with metal. So in this case, we'll leave it at 0.125. We have a 40% step over. Now that only really applies when you're pocketing, and think of a step over as like when you're mowing your lawn. You do the second pass, you want to make sure you overlap the first pass so you don't end up with a strip of grass that's not cut. Well, in this case, we're overlapping by 40% of the tool, but that only applies when you're pocketing. If you're removing a large section of material, that's where that'll apply. But in this case, it doesn't. We can talk about pocketing in a future video. So you can leave that alone. The RPM, if you're using a HF500 spindle, the RPM is controlled here on the spindle speed. If you're using a Crest or a DeWalt or a Dremel, you're going to have to manually adjust it on the spindle itself. Now, in this case, we're going to start off at 15,000 RPM because we're going to use an HF500 spindle. Now, the maximum speed for a STEPCRAFT 2 machine is 50 millimeters per second. So we're going to switch this to millimeters per second. And we know that if we are at full speed, we're at 50 millimeters a second. So my other rule of thumb for the first time you run a new job on a new material is to go half the speed. So we're going to set this to 25 millimeters a second. And the reason for that is because on UCCNC, when you're running the machine, you can increase the speed on the fly all the way up to 200% or twice the set speed. So as this job is running, you're going to go and you're going to increase the speed until you get to a point where you're like, okay, that's really good. Any more than that, and I'm stressing out the machine. And in this case, at an eighth of an inch per pass, you may find you can go all the way up to 200% or 50 millimeters a second, and you're fine. Now the other option is when you come back to do this again, when you cut the next piece, you may find that you want to go deeper per pass. So you could change this to 0.25. And maybe that at a quarter of an inch per pass, 25 millimeters a second might be okay. So the point is that you can adjust the feed rate on the fly. You can also adjust the spindle speed on the fly when you're using an HF500 spindle. So this is just a starting point. Now, say I ran this job and eighth of an inch was good, and I was able to run at 45 millimeters per second, or maybe I went up to like, instead of 200%, I went up to 180%. Now I can come back in here and set this tool again and reset it. So now instead of 25, maybe I'm at 43 millimeters a second, and I save it. And what's going to happen is from now on till the end of time, every time you do 3/4 inch MDF with a 1/4 of an inch end mill, this feed and speed rate is automatically going to be set and remembered from the last time. So you don't have to go through this process every time. And that's what's nice about the tool library. The plunge rate is how fast the tool dives down into the material. Typically, I usually leave it set at 10, and that, for MDF, pine, wood like that, you're more than adequate. If you were using harder materials, you would want to increase this because you want the tool to go into the material a little bit slower. So that's it. We're gonna leave this set. That's my tool setting. Our MDF. We're gonna click OK. We're going to see here, in order to make the cuts I want, it's going to do 7 passes. Now you can click this and you can edit this as well. So you could, if you want to automatic, say, I only want to do 4 passes. You could select this to 4, and you'll see here that now you're going to do 0.1913 inches per pass. It'll automatically calculate. We're gonna leave that alone just to see how this job is going to run for the first time. And now we know when our machine vectors box, this is where we're going to tell it how we want it to cut this line. We can cut on the line, which would essentially with a 1/4 inch tool would be cutting material an eighth of an inch on either side of the line. We can cut outside, like we just discussed before, or we can cut inside. So in this case, we want to cut inside the line. There's a direction. We can go conventional, which is counterclockwise, or we can go climb, which is clockwise. Again, certain materials are going to cut better in one direction than the other as far as the movement of the tool through the material. So you have to kind of, there is no set thing. All I can tell you is that when you'll see, I have to cut 2 more sheets of this. So I could set up the other sheet to do climb, and I might be able to set it faster or deeper per cut and see how it compares to the first one. In this case, I'm just going to leave conventional to start. Again, there's no grain or anything on MDF, so grain usually affects the direction that you're spinning at, that you're moving the tool. So basically, we're allowance offset. We're not worried about that. We can get into that in a future video when we talk about using V-bits and things like that. Use vector start points, meaning don't optimize. I usually like to uncheck that. I like the software to optimize where the tool starts. So if your vector start point was here and you just get through cutting this out, you don't want the tool to have to move all the way back here before it starts cutting. You want it to be optimal with non-cutting tool movements. So I usually just select that or leave it unchecked. You could set to do your last pass as separate with maybe a thinner last pass. In this case, we're using wood and we're planning on cutting into the spoil board, so that doesn't matter. Now, the only other thing down here, lamps, leads, ramps, order, corners, tabs. Tabs is one thing you may want to consider using. To add tabs, what's going to happen is when the tool cuts out the profile of this part, or for that matter, when it cuts out this circle, it's gonna remain free. When it makes the last pass, the circle is just going to remain free. The problem with that is, depending on the material you're using, if this is free, you run the risk of it vibrating and like hitting the tool and jamming. Or if it was really thin material, you know, as soon as the cutter makes that last piece of cut, the cutter will grab this circle and then shoot it out of the machine. So for certain materials, you can assign a tab, and basically what that does is you can set the length of the tab and how thick the tab is, and then you click on the material and it's going to have basically little pieces of uncut material that you would have to manually cut out later with like a razor knife or razor blade. And what those do is those hold the material in place even after the entire profile has been cut. It just keeps your workpiece neat. And if you have warped pieces of wood and stuff, that's a very useful thing. With MDF, I'm not going to worry about it. I don't expect that the pieces are going to be heavy, and I'm not really worried about movement on them. So we're gonna kind of skip over tabs on this. Now the other thing we're going to do is we can name this here just to keep reference of it. So I'm going to put circle, and then I click calculate, and it's going to come up with a warning. It's going to tell me that my material is 3/4 of an inch and I'm cutting deeper than that, and it's basically warning me that it's going to go through the material into the bed, but we don't have to worry about that because we're going to have a spoil board down. So we click OK. And one thing I could do here is I can change the look of the material. It really doesn't matter much here, but you know, I could change it to cherry or dark wood, maple. You know, you have the option. So if you were really doing something like a sign and you were going to paint things later, you could set the material up so it looks pretty close to what you're doing. I'm just going to leave it set to pine because the contrast is good. And that's it. So now what I want to do is I want to click preview all toolpaths, and what's going to happen is you'll see that the circle's cut out. I can rotate my material and I could see that it cut all the way through. And if I want, this is waste material, so I could double click on it and it just goes away. So now I see that my circle's done. So that's only part of it. Now we got to go and we got to set the toolpaths for the rest of the job. So we're going to click back over here on the drawing tab, and we are going to highlight everything this time. And we're going to hold down the shift key and we're going to click on the circle to deselect it because we've already cut it out. Now what we're going to do is we're going to click on the profile toolpath tab, and everything else is going to remain the same from the previous toolpath. So we're going to go down 0.765. We're going to use the same tool, the MDF tool. It's still set for 7 passes. This time though, we're going to click outside the line. And again, you have conventional and climb as far as the cutter, the movement direction. We'll leave it still on conventional. Again, we're not using tabs on there, so it's pretty straightforward. Now all we have to do is click calculate. It's going to warn us again that we're going deeper than the thickness of the material. Click OK. Now what we'll do is reset the preview, and we'll click preview all toolpaths. So now you can see that this emulates everything being cut out. You can hold the mouse button and move it back and forth to rotate it. And what we want to do is just make sure we're cutting all the way through. One of the nice things about this feature, this preview feature, is it's 99% accurate. So if something doesn't look right here, it's not going to look any better when you cut it on your CNC. So you could save yourself a lot of time, a lot of wasted material, broken bits, and everything else by really utilizing this feature. You can zoom right in. I mean, the detail is incredible. I can see like right here where when this tool is going this direction and then this tool is coming in this direction to cut that out, it makes like a little V. So it shows you all of that, which is important when you're working on stuff. Now, one cool thing here is if I double click on the waste material, it goes away. And what I'm left with is the pieces that I am going to cut out. So I double click on the circle. So there's my speaker side. There's the other side. Here are the inner rings, which are all going to get glued together. And that's it. So now all I have to do is select this toolpath list, because both of these tools use these toolpaths use the same cut-in bit. I don't have to change tools. so I can lump them both into one file. And what I'm going to do here is I'm going to click this button, which is Save Toolpath. And you'll see right here, output all visible toolpaths to one file. And because they both are using the same tool, it has no problem doing that. If you had 1/8 of an inch and 1/4 inch, a warning would come up and it would tell you have to save them separately. Now for STEPCRAFT Machine, we are using the Mach 2/3 ARCS mm.txt profile, the post processor. There's a lot of post processors in this list, so that's the one you want to choose, and it comes standard in every copy of VCarve and Cut2D. And the last step is really just to save the file, and I am going to cut out box and let's say sheet 1, because there's going to be 3 sheets total, and I'm going to click save, and that's it. We are all set to take that G-code file over to our STEPCRAFT with UCCNC and cut out these 4 parts on the first piece of MDF. Okay, so now what I want to do is I want to show you how to set up the next sheet, or the next 2 sheets for that matter, because remember we have 2 of these pieces here, but we need a total of 10. So we're going to make 2 more sheets of 4. That'll give us the 8 we need. First thing I'm going to do is I'm going to highlight these 2 pieces that we don't need duplicates of. I'm going to go over to the move tool, and I'm just going to move them off the work area. So I don't want to get rid of them because I want them there in case we have to do any more cutouts on this job in the future. Then I could just recall them and they're off to the side. So I'm going to highlight these 2, and I'm going to copy it, Control C, paste, Control V, and I'm going to slide them over. Now I could you move it by hand, that's no problem. Try to line them up. It really doesn't make a difference, but in this case I'm just going to go back and use the nesting feature. So I'm going to highlight all 4. I'm going to click on nest, click preview. It's going to line them back up with the same optimal settings we used before. Click OK. So now what I need to do is I need to make a toolpath for these. Since there's no holes or anything, this is going to be all profile outside the line cuts. So I'm going to highlight everything, go over here to Profile Toolpath. Everything is going to be the same from the previous, 0.65, 7. The tool is the same. I'm going to be outside the lines, and I'm going to go down to the bottom, and I'm just going to rename this interior parts sheets 2 and 3, and click calculate. It's going to warn me again. I'm going to click OK. I'm going to make sure that just this one is selected, the other 2 are not. Click reset preview, and I'm going to click preview visible toolpaths. And that's going to show me these parts, and I can double click on the waste pieces, and I can see that I have my 4 inner rings. Everything looks good. I'm happy with that. I'm going to check the interior parts sheets 2 and 3, and I am going to click the save toolpath. Again, everything should remain the same from the previous, the Mach 2/3 post processor. Click save tool, and I'm going to call it cut out box sheet 2 and 3. I'm going to click save. I already had a file in there, so I'm just going to overwrite it, and that's it. So now we are all set with this. We have 2 files. Basically, we're going to run the sheet 1 file one time, and then we're going to run the sheet 2/3 file twice. So we have 3 total pieces of material to make all the parts required for this particular box. So we're going to head off to the CNC machine, and we're going to show you how that's all done in the next video.